I'm live. All right. So let's go for another wonderful afternoon. And today we're gonna still work on the pattern of Ralph Wiggum, although my microphone is needs some adjustments. Where is our audio player? Where is the media, the desktop audio? Which this one we should remove. And we should remove this. We should worry about our desktop audio. If the audio is too loud, let me know. And I think we are ready to go. So what are we going to work on today? We're going to work on the Ralph Wiggum pattern self-improvement software. And right now you can see we have our tasks running right here. We're executing on step 4. And I think the idea was to implement implement Ralph Wiggum in C#. So now if anybody wants and is interested, please take a look at what we're building here. So now it has a CLI options. What are the CLI options? Okay. We have quiet mode, resume mode, improve mode. And that's the list of our arguments. Just looking at the code that it's producing, which is very important. Well, this is an idea I want to have is okay, we can explore, refine, plan, and execute. Now I want to ask Ralph if I want to ask Ralph if what we are doing is important. So, we're gonna go back to first principle. So in fact, well, good. So now let's start with the basics, first principles, to kind of lay out the scene. So first principle, let's lay out the scene so we can understand from start to finish what we're trying to build here. Let's start with the problem case, the solution. Okay, so let's go in our program.cs to really understand what is going on here. But after the terminal run, we'll do that. So because this is important, what we're doing here. So it has the static thing, and I think we have added, okay, so this is the summary of what he has done. Instead of inline argument parsing, now we are doing the test. So let's go with our helper application. We're going to have a helper application that we're going to go, it's going to call its slides. Okay. Let's say cloud. Okay. Yeah, all I want to say is kind of let's see what this is doing. So it's running. So as you can see here, it does the tasks all by itself. And I added this little summary, so it's not like opaque. So it feels like it is doing something, and that nice little animation that's going, so that we don't know that it is frozen. And if we want to look at the refined, there was an option to actually see the file. Okay, so this is the refined idea. This is the raw idea. Let's open the raw idea. See, it's all about extract argument passing into a second class. And second task is that it's improving our prompt templates. And the third task is creating a post pipeline, which is basically after we've done some work, we show our workspace, we show our git diff, the file we worked on, did any tests pass, have we recorded our changelog in some asynchronous comment runner. And we also need to create a pipeline runner that basically takes a CLI options, better loops, better event management. And then we slim down program.cs because it was so big. So we put some other things in here. So this is the flags when they say Ralph, improve CLI, UI UX, code, improve test, improve performance, improve custom area. And then we keep the existing functionality working. We don't want to break anything. And then we also want to make sure that everything is passed. So in that case, what we are going to do again is to see, should not break it. So let's look at the result of our build. And Ralph is still running. I wish it gave me the total time. So that's going to be another prompt. But so this is the part. We have visibility on the code. It's not like this black box and we don't know what's going on. So we have the loop controller. If we open this file, it's very long. It's too much. So it's working, but it's too much. I think I'm going to review. Okay, so first I'm going to say, I'm going to go into my cloud. I think this, let's see how long I've been talking here. Okay, I'm going to say basically, although the improvement is working, I'm looking at the code here, the loop controller. Loop controller is 500 lines long. How come? Why is it 500 lines long? It's hard to grasp for me. Please explain. Okay, so now it's going to explain what's going on here. And I think this is why we have to kind of, okay, this is too much because it seems like it has put everything inside of the, there's a lot of cases. I don't even want to read this. I don't know even where to start. And also I don't like this kind of string interpolation slash variable thingy. It's also doing some transient patterns. Like there's some interesting stuff. It's a result of what we've accomplished, but we are going to do it in a much better way. Okay, I'm going to say that what is my current, okay, oh, okay, let's have a simplified model. So, but also we'll need this kind of prompt manager. I think that's important. Why? Because common prompts that we can delegate to agents. Okay, now it says that the structure of the loop controller, why it's big, it's doing 6 jobs: pipeline orchestration, execute loop, plan parsing, prompt loading, error handling, summary. Okay, So you can extract things. Let's see, has Ralph finished his iteration? Ralph is still going. Okay. Okay, let's have an improve, but the improve is going to keep the working functionality, but we remove all the fancy schmancy stuff. Okay, can we have a working thing, right? What do I mean by that? We have a giant truck, or we have a giant oil tanker. But our goal is we want to go from point A to point B at, let's say, 60 miles an hour, like a train, or whether it's by foot or whether it's by car, we're going to go eventually to the outcome. But right now, we are trying to move, we're trying to create a factory, but it seems like it's a giant industrial complex. We still want the same thing, but we want to make it in a more trimmed down way with the exact same functionality. What do you recommend? Okay, so now we have to check. Okay, Ralph is done. Ralph has this new post pipeline that okay, so the build has failed, but the test have passed. So our build has failed. So let's say .NET. Actually, I'm too afraid to run that. Let's wait for our, okay. Before I break anything, I'm going to go here and I'm going to, okay. Okay, so we can write it. Okay. All right. I think instead, let's have a JSON that is also tied to a prompt that is basically a series of 10 auto-rotating slides with some visuals. So we'll need a mermaid diagrams and SVG or any other thing that will show as slides. Okay. Now, how lean do we want to go? I'm gonna commit these changes first. I want to keep my spinner. So my spinner is this component that gives us the visibility, and I like that. I don't want feature flags. I think it's the branches of the improve. We have too many improve options. So I would want to, and how do we start fresh without breaking anything? So while this is boiling, because we started with Ralph, we also have this Ralph activity. Let's go to our, we have two things. Let's go to our log. So Ralph tells us what he done. Ralph said, this is my session. This is the duration, 15 minutes. And this is my workspace. And this is what loaded the prompts you see in sequence. So we have a lot of data to work with right now. And this is the raw idea. That's a raw idea. After it has gone through, let's actually open the preview to actually see. So we have the raw idea. Let's increase. So okay, this is the raw idea that Flask came up with. Then it modified it. Says this is the files that we're going to do to fix that, and then this is the tech stack. It identifies C#13, .NET 10, ASP.NET Core, but console application, Okay, we're going to get some JSX, but you will adapt that to our project. It's basically the concept of Ralph Wiggum, and we're going to improve our, so you can adapt that into our slide system, see that as a new workspace, and we want it to fit kind of like, think of it like a portrait mode. We'll explore that. Okay, so then after that, this is the code base. So now you get the point. But let's look at the log that Ralph has done. This is the log for Ralph. Okay, and we don't want this. The logs for Ralph are kind of like this. They can be very long, depending on what we're trying to do, right? How many lines? About 700 lines. But it's important to gather this data because, you know, it starts, quiet falls, it deletes, it tells me this is what it deleted, this is what it is saying you will get the most kind of like essential parts of it since we have that huge code base. And also we still want to keep the logging, we still want to keep the change log kind of stuff, right? What part? Okay, let's actually do it like that. What part will you keep? What part will you remove? And I think we don't want to overload program. I think my architecture would be, we have the program, we have the loop controller, we have a prompt manager, and we have maybe a task queue or whatever else. But let's do it in 5 files. Let's see if we can do it in 5 files, 5 coding files, and then the rest of the stuff could be docs and whatever it's needed. But let's see. I put some constraints into the system. So our 5 files is program, the loop controller, the episode runner, the console spinner, the debug log. What do we remove? CLI options, helpers, status dashboard, model, interfaces. We're not using dependency injection, state sync, wisdom service, wisdom API. Yeah, we don't need that. Migrations, clarifier agents, expert agent, planet session, prompt manager, hiding line into loop controller. What gets simplified? We're gonna have the pipeline with the 4 stages. We're gonna have, in fact, I'm going to screenshot this because this is important. I'm going to actually say for now and remove all of these. That's the lean version with 5 clean files within your drive. Okay, I think that's good enough. In the meantime, let's go back to our conceptual arrangement. Let's see what's going on Hacker News in the meantime. Wow, this is loading. Let's see what news we have on our. What news we have. In our Chrome window, we're gonna see what we can see. We're gonna go into let's see, where's our window cap? I have so many windows open. Where's the taskbar? It's disappeared. Let's see now if our okay, windows are back up. So this is the news that we can actually see. It seems like Hacker News has discovered what do we have here? Prism. That's actually fresh. Let's see what this is about. Prism, introducing Prism. Prism is what? Prism is an accelerating science writing in collaboration with AI. So they are actually kind of getting into scientific papers in science writing. So it seems like it's going to make people write, make better stuff. And it's a workspace for scientific writing in collaboration with GPT 5.2. Brings drafting, revision, collaboration into the system. I have to put my glasses on so I can see better. And what do we have here? It also comes with GPT 5.2 and stuff like that. Let's see the comments. What do they say? They're saying that as a journal editor, you know, Hacker News people are going to do that. It's kind of funny, but it's interesting. Those comments are actually good and useful because they kind of give a different perspective, and it's almost like a pushback against where was this found? New York Times in Europe. So now we're kind of Ralph is kind of asking, should it run the command, the bash command? And we want to, okay, so now he's gonna remove the agents. It's kind of refactoring all of so you see we have the logs and we have our prompts. So we have 1, 2, 3, 4, 5 prompts. Yeah, execute. We have explore. In fact, let's go on our big thing. We have the explore. We have so you see explore mode. It just tells it this is what you should do, what stack, what language. Right, stuff like that. Very simple. I feel like it's working. I feel like I should have a lot of screen real estate is lacking. We know if our window is resized almost in portrait mode, most of that should be seen, and I think we can increase our font size and make better use of the screen real estate. So for now we have kind of like, I don't know if you can read it, but we're removing hard stops and we want to have this it's hard to, we're gonna appear, so we're building, you know, files are messages. We have the insights. Okay, okay, so now what's going on in our pipeline? What is Claude says? Claude says that now we have those comments. We can .NET run, we pass our idea, we can improve, we can resume, and we have the logs. So now on the branch called lean, we want to test it. Okay, so let's test it. I would say, what would be a recommended first test? So in the meantime, we're going to commit our changes, stage all, and we're gonna say, let's let the AI just the Copilot do what it does best. That's why Copilot is good for, so we use that. Commit. Okay, so now we are going to check we're going to check our file system to see. So we're going to actually go into, we're gonna say specs, we have templates, Um, Before we do that, I even want to see why we have a lot of dangling markdown files that probably should be discarded. We don't have to archive them, we can discard. And yeah. And then we're going to go with that prompt. I think it's important to read the code and be inside of the code, you know? Otherwise, it's easy to just be tempted with the it's easy to be tempted with the speed, but what is that for if I have to go back to fix it again? So can I rename this to folder? I guess we're gonna call this then. Okay. Now remember, okay, so this is all the files. We're going to simplify our system with this. And for anybody who's watching, I'm going to put this in our we're gonna put that in our live stream because so people know what's going on. Now what if I refresh the page? Okay, I think on mobile the sidebar should disappear entirely, and we should increase our font size. And I also think the dark theme is not very readable. We have too much white space. It's like we are very condensed, so we should increase the size of our graphics, increase the size of our text, maybe have a more readable font. Okay, so we want to keep the history tracking. We should keep the history tracking. Well, I guess we could keep it as changelog. Yeah, keep it as changelog. We keep principles as well because principles are important. Okay, do another round of. And also, what's the difference between the templates and prompts? Actually, let's remove the outdated kind of prompts because you know. Let's do it like that. Our prompt manager loads the prompts in the file where it is. Or should we? Let's do that for now. We might have an issue with parsing the markdown file. So we could, if it's easier to parse it as JSON, because all of these are important. I think this is where the technical skills starts to shine because we don't trust it 100%. Actually, I'm going to put that as an insight. I'm going to say that okay, we should get a 20 list of insights based on AI assisted development, Ralph Wiggum and software development lifecycle. Okay, so now it says, okay, I'm gonna allow it because now look at how much we have. We have the console spinner, which is important. We have the cancellation token. Let's reduce the size of this to refresh. Let's go to Ralph. Okay, so now if we put that on the side, we can start seeing a little bit more better. Okay, so we can move this here. Okay, so we don't want to keep everything right. We have to understand that the memory will degrade over time. And so let's see if we can slightly decrease this. Okay, so as you can see, we are in this strange Okay, give me 1 second. I will come back, okay? 1 second. Let's go to please enjoy. Well, okay. So hello? Oh no. Come on. Really? Oh, c'est vrai? Bon, checker pour moi. Attends, bon, sur ordinateur là, bon. In. Malina. Ça dit track package. Ship FedEx. Out for. Okay, bon. Voy tracking number à vous. Bon, ouais. On va monter dans tracking number à vous, moi, ça veut dire. Sorti Tennessee. Bon, ouais. Passer Las Vegas. De Las Vegas. Memphis. So, bon, moi, qui côté Tennessee, ça est là. Tennessee. Oh, c'est la Miami. Oh, ok. J'aimerais le dire qu'à arrive même jour aujourd'hui, bon, je dis entre 27 à 28. Oui. Ouais. Oui. Et surtout avec neige là, tout, gros tempête, ça m'a comme ça qui arrive. Ouais. Oh, mes amis! Et à Magédon. Je fais n'importe. Oh, c'est pelé. Bah, je vais, non? Et pour un cas de ça parle bien 3 ans, nous venons et type de neige ça. Oui. Et bon côté pour qui j'en lié. Ah. Et on fait frais qu'on y a là? Ah. Ah, ok. Ah. Hmm. 40. Oh, 40 c'est vraiment fort pour moi. 40 tape frais pour moi. Déjà. Ça veut dire qu'il y a une manche longue, tout bagay. Voil ba ou la, oui, me fait voil sur WhatsApp. Vous pouvez checker tout. FedEx. Ou t'as aimé pour setup li. Oh, à parler de tracking number, c'est sous site FedEx là. Vous t'as monté. Bon, est-ce que vous avez un site là pour vous? Et pour on est rentré numéro et puis là pour ou bien qu'à checker périodiquement pour vous tout. Bon, ouais. Et vers zone. Oui. Ah. Ah, ok. Bon, voilà. On va faire une surprise. Ah, c'est bien. Oui. Oh, ça fait jeune. Mhm. Oui, comme ça. Mhm. Oui. Mhm. Oui, saute le travail. Oh, ok. Eh bien, grâce à Dieu, oui. T'as chanté matin. Et non, pas t'allé jeudi, elle t'allé hier. Jeudi, elle off, oui, tout. Mhm. Oh, bon, hier, là, toute neige, là, allé. Malgré que neige chape tombé toute journée. Oui. Hmm. D'accord. Oui. Pas un problème. Ma checker encore plus tard pour moi. Oui. Mais beaucoup, il y a. Oui. Parce que je regarde la map. Yeah. Tennessee. Dernier, yeah. Côté où dit là, Tennessee, qu'on y a. Oui. Son état et. Hmm. Nashville. Et entre Georgia, entre Florida avec Georgia. Avec, oui, oui. Mais ok. Pas d'attendre, oui. D'accord. Ok, enfin, bye bye. Okay, so I think so. What should we do here? Okay. Yeah, what should we do here? You know. So did I even have my camera on? That's so funny. Well, uh, if you understood, you understood. But it's okay. Uh, let's see, let's see, let's see. Uh, okay. Well, let's embed it in the code. We can have a string, or yeah, I think it's easier. But whatever is easier to edit. Uh, okay. So now let's go into our slides. Let's go and we wanted to adjust the timings. We want to okay. So now Ralph, we're gonna do another round of the Ralph thingy. And so I think what we can do is good so far. I think now we need just a little more kind of maybe the control should be a little more thin, and the delay between the slides should be maybe 3 seconds longer. And okay, so now it's loading. So let's look at our principles. The principle is saying that, you know, Ralph is not gonna need it, right? Ralph is not going to need it. Keep it real simple. Simplicity first. And what is the scope? We have the prompt updates, we have the no web UI, no database for now, no plugins. We're gonna do raw NC, but we might actually investigate any text over user interface. So what is a TUI? Well, we'll see what the TUI is. A TUI is this. It's a TUI is a C#. Is there any framework for TUI? Well, we did something that's they have terminal GUI and Spectre console, which could improve the let's see what this has. Ooh, this could be a great contender for our improvement. So we'll explore this once we've done the round of simplification. And that actually could be really good. Let's actually, you know what? Let's actually move into this space. We're going to, that will allow us to have parallel. Yeah, we're gonna use this one. It has a decent amount of followers. Let's see, a ratio of close versus open. I mean, it's definitely pull request what's going on. They want to flip orientations, pop over, more robust, those kind of stuff. So, okay, so remember, the problem here we're trying to solve is it's better to have a dumb worker that is reliable than a very genius that just makes some stuff, you know. And this is what Ralph is. Wakes up, reads something, does something, dies. Wakes up, reads something, doesn't need to know what happened before. It just executes the one task, mark it done, goes to sleep. The pipeline, we explore the idea, we refine the idea, plan it, we execute it. Explore, plan, execute. Okay? So now let's go into our tech stack. We are using pure C#. So no frameworks, no nothing of the sort. And I'm going to kind of make sure that it's using the latest C#. So we have the raw idea, we have the code base, refine it, and the files are messages. Simplest protocol, right? This is the simplest protocol. And so far we've had a great amount of success and no human help. But before we do that, we have to do like some housekeeping. We have to do some housekeeping. Let's refresh the page to see what's going on. Go to Ralph and let's kind of give it, put it here while our trusty user interface is working. Okay, so now let's see what it has come up with. It said that it wants to delete the prompts. So this is the prompt manager now that we have. Our prompt manager, we have the explorer. This is the string. We say you're the explorer. Let's collapse this to refine. You take an idea. Where's the variable here? We take the idea and we refine it. Let's collapse this. We have a planner. You're in plan mode. Your task is to create actionable task list. Okay. Then we have our execute. And then that's it. So we have 4 prompts. 1, 2, 3, and 4. So now what we're gonna do is we're going to continue with this loop. We're gonna start another loop. Are you ready? We're gonna start another loop of Ralph, and let's see what Ralph is going to tell us. Okay, we're gonna start another loop very soon. Once this idea is refined, let's increase the font size. Let's go and let's see what we have here. Okay, let's okay, we're gonna say here is another round of ideas that you can incorporate into the slides, and let's make it a little bit more interesting this time. Okay, so now we're gonna allow it for his project. Let's look at principles. Okay, This is the big meaty part of the thing. This is the big meaty part. It's this. We take an episode. Actually, we shouldn't look at this code yet. Let's look at another code that's more important. Let's close this. Let's see. Okay. We have program. That's the entry point. We have our pipeline. That's the orchestrator. We have the episode runner. We call it episode because it's in theme with our stuff. We have the prompts. We have the console spinner. This is to give us activity, and we have our debugger. Okay. And our templates. Templates are like directives. The first one is improve the idea, but we'll go back to this later. And we have our documentation. So we remove the prompt folder and ready to test. So let's actually go into, let's commit the code first because we don't want to lose this. Let's go. And we're going to do a .NET run help. Let's see how it behaves. And we're actually going to quit. And this is the part we don't need long running operations anymore. Look at this. I've taken my time to ask it the right questions, just the right questions. We're not writing a lot of code yet. We're just going little by little. Okay. So now I can safely quit this chat because I don't care about it. Now I open a new chat. Okay. And I'm going to say, push this here. I'm going to open my terminal. And then this was the previous Ralph one. So let's see how Ralph run now again. Gonna clear. We're gonna say .NET run. Yeah. Okay. And this is our help. Well, this is not good. Let's see if it has bypassed. Okay, it's building. I don't like this flag. Okay, there you go. Ralph is active. Let's actually move this here so you can see better. Let's move this here. Okay. So Ralph is working with us. I'm next to Ralph. Ralph is my co-worker. Hey, Ralph. That's me and Ralph working together. So it's exploring and it's taking some time. As it's exploring, it's writing files too. Look at that. Look at the file. It started with a raw idea. And this is the thing. It has an idea, help. We'll see what's going on. This is like primitives. We're doing a primitive operation here. We are making it build the help for itself. So in fact, I should write this in our chat. I'm going to say, right now we're using Ralph to build Ralph. Okay. We're using Ralph to build Ralph. And it's exploring. It's going to have a new file very soon. Just watch. It's gonna have a new file soon. And this is the new file. It has generated this file called codebase. And it has generated a new file. And the file has, it says, okay, we have entity framework, SQLite, but it's not used. We have our unit tester. And this is our project structure. He has figured that out for us. And it has the entry points. And it gave us, you see, we asked it for something and it gave us a good answer. And now it's gonna run still. Let's see what he has come up with. Ralph is still running. Now it's planning. It is going to see how it can improve the help of that command line. So this is the refined idea. He's created a refined idea for us. Isn't that great? Isn't that wonderful? So Ralph is doing work for us while we are thinking. And I think we want to actually look at it here. We want to have this conveyor belt. And to do that, I'm going to... so now it's going in principles. It's executing. It's going to update our program.cs for us. And let's see. So you see what's going on here? We are simply letting it do the work, and so Ralph is waking up with 0 context memory, right? And that's what makes it so powerful. It executes one task, mark it as done. And now we have practicalities. Let's see what's going on here. So memory and state, less is more, right? We start fresh. Amnesia, it forgetting stuff is actually a feature. It's not okay. So we can say good. If the window is resized, it should not overflow. We should keep all things within its own container. So like the next button should be within the boundaries of the code. Okay, and here we go. So it has, after it finished, it tells us exactly what it has done. So now we can basically, it has improved itself. So now we also, let's go to next. It's verifying. So now it's verifying, and it says the build has passed successfully, but now it's just verifying the code for us, which is kind of cool. Now, what should we do next? This is the idea. So now we did the idea collector. Okay, we need the idea collector. So we are going to go into our Ralph. We can go into a new slide, but we also have structure. And let's go back to Ralph. What we're gonna do, as we've discussed earlier, is we're going to implement this new tool called our text over user interface, which is what we call a TUI. So we're going to implement this TUI, which is going to make our so what is a TUI? This is a TUI, text user interface or terminal user interface, and this is what it looks like. So we're gonna see if we can. I've started implementing a version of it myself. In the proudest idea was this trailing. Now it's planning. So it's finally done. It did 2 tasks. And now we are ready to start again. We are ready to start again. We are ready to start again. Yeah, Ralph is doing the work for us now. 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 Okay. Okay. So let's check our changelog, our code base, and I want to see if it would help. .NET run. Well, okay, so we have an issue here, is that we can run flag with resume, we can run flag with improve, or we can pass in an actual idea. So we're going to test this prompt here. I'm going to commit this first to see if it works. So we're using Ralph to build Ralph, okay? So we're going to say, we're gonna go here, and I'm going to copy this here, and I'm going to say, I would like to implement the next version of Ralph Sharp as a two-way. We're gonna give it a simple prompt like that, and we're gonna see if it's going to do some work for us. Okay, so you see we have our split screen, which is not the most perfect, but let's go back and let's see what it's doing here. Okay, so it's going to actually, to make sure that everything is working fine, let me commit this. Okay, this is the raw idea, and it has given us the raw idea. It says, I would like to implement Ralph Sharp as a two-way. You see, before it was help, it replaced it, and this is in light. I think we I think our buttons button at the bottom is has some artifacts. We can make it simple, previous, next, blank, but just bold text. And so now it's in the explore phase. So it's exploring the idea, and it's gonna come back with okay, only 1 minute. We haven't touched it yet. So it's following the prompts that we have set aside. It's gonna watch. It's gonna have the thing very soon. But let's actually amp it up a little bit more. Let's refresh the page. Okay, so I think what our application is lacking is a proper responsive management kind of framework. So it knows that if the window is mobile, that it should redraw the screen better. Okay, so let's see. While this is loading, let's check our text over user interface. Oh my god, look at that. It actually picked up the principles, and it's running without pauses. So let me actually put this up. So okay, we're gonna let it do it here. So it's at stage number 2. Okay, so now let's split our terminal so we can we tail the log? Let's tail. Oh my god. So now it's gonna clarify itself. It's clarifying itself. It's clarifying itself. Yeah. Ralph is the future. Ralph is the future of software engineering. Software engineering. Software engineering. Yeah. Software engineering with Ralph. Okay. Software engineering. Okay. So it's only taking 3 minutes so far. Not long, really. And has it come up with an idea for the code base? Here's the refine. Oh, it gave us a plan. It gave us a plan. It gave us a plan. Let's look at the plan. So you see, it removed the old and put it with a new. So let's just look at the new. This is the plan it says it's gonna come up with. Status dashboard. Okay. So we were too vague. It's gonna build its own text over user interface. Okay, we'll let it do it. We'll let it do it to see if what it's gonna look like. I mean, maybe it's going to look better than what we currently have. So, okay. So now, Okay, good, but I think we can increase the font size again and increase the font size of the graphic to fill up the space. And we can even split it in half. At the bottom, we can kind of have this input currently working on, and it's going to basically say current task is to uh, do make Ralph build Ralph. Okay, so now let's check our browser again. We're going to um, talk about this idea that so I'm next to Ralph, and Ralph is being okay. So it's okay. We're gonna say let's chat with the Claude in the meantime. Okay, let's chat with Claude in the meantime while it's building. Okay, I'm going to say, can you explain the current architecture that we have based on our pending changes and describe the workflow for us? Okay, so now it's exploring our code base. I think also our user interface, we should have a padding at the bottom for Ralph. Okay, should have a padding at the bottom. It's adding an event hooks controller, only 70 lines. Okay, let's let Ralph work while we explore the ideas discussed in this thing. Double the font size of the smallest text and add some bottom padding to our controls so it feels more alive. It's analyzing our code, right? It's analyzing our code. And let's see the status of Ralph. Okay, so it's working for a bit. But let's explore our C# code for now. So we have a program, okay? The program is our current workspace directory, right? Let's actually go in here. Let's so all we have is this is our current directory. Idea is the main entry point. So we start from scratch always. We're not gonna improve it. Okay, now this is the loop. It's checking for arguments. So basically saying that we can pass a different workspace, or we can make it resume from where it left off, or we can ask it to improve itself, or if there's an idea there's some text and the text is empty space or like that. This is actually strange. I don't understand this part. Can somebody expert at C# explain what's going on here? Okay. Now, when you choose a flag, it basically loads a prompt. It looks at a template, and then this is a fallback. If it's to resume, we tell it the idea and Ralph improve. I want to see if I can call it Ralph. Okay, and then this is all the files, and that's the loop. So on writes the line, tells us what's going on. Okay, so now let's see what it has said. Remember, our pipeline is our text should be even bigger. I'm talking like the text, the description text should be even bigger. Okay. So we explore the idea, we refine it, we plan it, we execute. So we have the loop controller. This is our loop controller. And we take a workspace. We say that we should not run it for more than 50 episodes. And we call the runner. We also said that it should have 25 turns or 10 minutes before we quit. It's either 25, that's like and then now we run the pipeline. This is the pipeline. We start with an idea. We can cancel as we're running. And then okay, let's see what Ralph is doing. I think did Ralph finish? Okay, it's on a new phase. It's creating the status dashboard. Okay, let's let it run, but we'll explore our code. So here, it takes an idea, and as an event is going on, is logging it. It's writing that to the file, and we set the stage, right? We write, we're on the exploration phase. We are running an asynchronous operation. We write what we're going to do. We're waiting for another phase, and we keep moving. So it's kind of like it's telling it to. Let's actually explain this part, because this is where we could use Copilot. Let's explain this. This is using. Okay, I'm going to go with Copilot this time. I'm going to say, explain this for me. Because if I don't understand it, if I'm not familiar with that part of C#, it's okay. Okay, so it marks the beginning of an explore stage of a multi-stage pipeline. It logs notify. Okay. More C# oriented. The syntax. Okay, so it's gonna tell us about the syntax. And let's play that. Okay. Like we can commit that change for now. Okay. Let's see if we can use a better. Okay, explain better. We're learning together here as we're going. Okay, log. I'm spoiled by the Claude. Let's go to Claude. Let's see what Claude will do. Copy. Okay, 5 selected line. Explain its lines. Let's see. So 36 to 40 is going to explain it for us. Okay. It says these lines are part of the run pipeline asynchronous. This writes a debug log indicating the explore stage. And if it has not been skipped, if it's skipped, we disable the logging. We fire an event. So there's a subscriber that's waiting for an event to see if the state has changed. Then it emits a message, and then it runs it. So it switches stages, basically. Switches stages and then runs what it needs to run. Okay, that's what this is doing. Now let's go down. We can see the same thing here until we finish. Okay. So now, yes, I think let's see what Ralph has been doing. Ooh, that's a jumble. Bad formatting. Well, kind of cute, kind of pretty, but not the most aesthetically pleasing, not the most pleasing thing. But it says it's finished. 5 tasks done. What did it do? Um, it did not tell me what it did. I think that's the part. He said it did some change on the console spinner. Okay. I'm going to close everything. We're gonna launch Ralph again to see how it fares. So we're gonna commit this change. Okay. Can you analyze our pending changes to tell me what is going on, what Ralph did? Okay. So we're gonna see what Ralph has done. Okay. I'm gonna say what mechanism do you use to build the slides? Okay, so what does it say here? It says that Ralph went through the 4 stages of the pipeline and it executed the framework and it tried to figure out what TUI means, and it created a status dashboard for us, and it added some hooks to the loop controller. So that's the planning. Then it executed that plan. What did it do? It basically said that we're going to do NC. If you don't know what NC is this kind of way of displaying text, and it's a very kind of like a standard, basically. I think ASCII is also another, but let's copy this. Let's go into our okay, we can see what this is doing. So it says NC is a standard. It's a standard 7-bit. I mean ASCII. So let's actually do it. Is it one standard? But okay. So ASCII is a 7-bit encoding. You can have about 128 characters. So it's American Standard Code for Information Interchange. And you can have uppercase, lowercase, basic punctuations, and control characters. It's universal. ANSI was made by Microsoft to just some different stuff. So added accented letters, what they call diacritics. So ASCII is universal and ANSI is regional. So they are now replaced, superseded by Unicode. Okay. Now let's see. Controller. So Ralph failed. For all intents and purposes, Ralph failed. It's okay. Why did Ralph fail? Because we were not specific enough. I think it inferred as a real-time status dashboard in raw NCC. Okay, we'll ask the question now. I have to ask it. I have to be more explicit. So that's okay. Based on this chat, if you had SVG, So give me 20 insights and a prompt for SVG. SVG as a slide. So give me that format in JSON and also add some little color stuff to it too. So this is to make it more dynamic. So we're going to then explore our text over user interface. So which we have here. I think this is the one we're going to use. It's called terminal.gui. And I think we'll have to let's copy this. Let's copy the repository, and let's now go back and let's simply grab this, and we're going to, let's wait for it. Let's clear our terminal because Ralph, let's clear it. We're gonna do another round of Ralph again, and we're gonna see what output it's going to give us once we are more specific, to see if we can have this wonderful new text over user interface. I don't know why I keep calling it text over user interface. I meant terminal graphical user interface, or terminal user interface. And are you ready? We're going to have another round of Ralph. Are you ready? We're going to have another round of Ralph. Let's refresh this. Okay. So we are ready to start another round of Ralph. Okay. So we don't have a lot of files actually. What is the path? All right, once I see, so it's in sharp insight that slide that is, which I do not see. You are invisible in our file system. But sharp insight slides.json. Visible. Okay. Show me the JSON. Okay, so let's analyze our status dashboard that Ralph has created. It's kind of underwhelming. Okay, I'm going to basically, while we're planning, I'm going to say .NET run. Let's see. It gave me a suggestion, but I want to say .NET run, .NET run, And our terminal, add bottom padding, and if you're writing, if you're and right, show the current task you're on at the bottom. Okay, so it's gonna run. I don't know why it has this thing here, but it seems like it says it's a dashboard. So it says it's a dashboard to kind of display some information up there. So it's exploring the idea. And to make sure that let's have a fresh one. Let's save them. Let's commit. We're gonna commit. Okay. And here are some new ideas that you can incorporate. Okay, it's exploring. 40 seconds. This is the raw idea. Remember, it starts with the raw idea. So whatever I've written, it replaces it with this new one, right? It replaces it with this new one. Let's actually change our theme. I think our theme is to... What do you think of this one? I know that not hacker enough. Let's keep that for now. Let's keep that. Someone. That's too dark. I want to save your eyes. So the colorblind. What about that green one? Let's try it for a bit. Okay. Okay. So now it's going to refine the idea. This is the refined idea that it gave us. Okay, that's the raw. That's the refined. This is the refined idea. Oh no, this theme would make me lose it very quickly. Please, what is a good theme? Can you make me some recommendation? I'm open to some recommendations. We're gonna keep the dark enough for now. I hope, okay. It's looking. Now it's gonna plan. Let's see the plan that it has come up with. This is the plan that it has come up with. That's the plan. It's gonna create a status dashboard. It already worked on that, so it's smart enough to mark it as complete. And mark this as complete. Mark this as complete. So once it's finished with the plan, this is going to be replaced. You'll see. That's what I'm trying to say. So if we want to, we don't want to overcomplicate. So like a Jira, okay. So people are familiar with like a Jira kind of thing that comes up with all these status, and it took like millions of dollars, to implement. Like let's actually open image, and that. Like in a way, we are kind of implementing. We have project, which is a workspace. We have a goal. Let's call it plans. Goals are ideas. So we can actually borrow the terminology themes are agents. Topics, you can call them tags. Okay, and then we keep moving from there. Now, this is another view. At some point, let's actually use that term called conveyor belt. Okay. We have a GIF that kind of shows what is going on here. Okay, so we have like pipeline of ideas or something like that. So we input things, move them to another side. Process. So this process is done. So now let's check on our Ralph to see what Ralph has done. And then we're gonna work on the basic principles of Ralph again to okay, Ralph is still working, and this is the plan it has come up with. It is going to have a bottom scroll region. It's going to update our status dashboard. Actually, we're gonna interrupt Ralph because, you know, we're not going to, it's going to do work for nothing. But let's let it finish. Okay, since it's already has built it and it's at already step 2 of 2. And look at that, it added color to its terminal. Ralph added color to its terminal. So this is something we didn't ask it to do, and it did it for us. No way, I'm pleasantly surprised by that, you know. Okay, so now it's working, and now it compiled the code for us, and now it's doing the rendering. In the meantime, let's look at our plan. Okay, it's too, we should add this directory to the git ignore. So we're going to say that we have copy this. I'm going to we have a bunch of DLLs showing up randomly in our pending changes. Please analyze that and let's ignore that. Okay, we're gonna ignore that. So we're still on the lean branch. We're not on our master yet. We're going to change to the master, and we can also say that let's see if it's cycling. Our slides should be random, and at the bottom of the page, let's add another illustration also that's fitting but this time animated. What could we pull? So files are messages, right? Okay, let's see.
Frère Jacques, frère qui boulaye.
Alf is still working, 11 minutes. It's going to Ralph is still working. What did it do here? It if after a few minutes Ralph doesn't work, we're just going to let's refresh this. Okay, so we're back to normal. Okay, so it was pulling a lot of okay. So this workflow is not going to work for us. Let's switch gears. Okay, we're going to clear this. I'm not interested in that anymore. We're gonna quit this. I'm going to let's see what he has done. Okay, status dashboard. Okay, we're gonna discard everything. We're gonna go here. We're gonna say git status. We're gonna say git add dot. Ooh, no, 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 no. Actually, let's actually. I forgot the thing. I'm gonna say committed by mistake. What's the git command to revert last add, not commit. I added some files. Oh, actually, I staged them. So on stage and then wipe out. I could do it here with the terminal. I mean with the button here, but I'm going to do it manually because I want to learn how to, or at least remember. Okay, so it I don't wanna. I don't want to undo commit, just on stage and then clear the pending. I don't want to commit them. I think on refresh it should autoplay. Please like the video if you want to see in depth in the most amazing. This is not like vibe coding. This is professional software engineering with assisted AI or language models. So we are actually kind of being very cautious to not just waste our tokens because our budget is important, right? The token budget. And we don't want to waste all of that just going back and forth with the AI. We want to make sure that anything that we do is actually makes sense so that we don't lose kind of track of the project, and also understand the code as we're moving forward, because the code is important too. So far, because if the project becomes so big that it's hard to know what is going on, then what is the point? I think we also are going to close this. And okay, we've discarded our changes. So before I proceed, I'm going to close this chat, and I'm going to basically, let's see if it explained our architecture to us. Okay, so I think we have enough context to basically ask it the question like this. Okay, now I think we've reached a stage where Ralph is sort of working, and I think our terminal is currently not the best. We could still use the command line, but we can add another layer of interactivity to it, and it would be better if we used a different framework. And I propose that we use this. So now I don't want Ralph to just go off the rails. Let's plan it in the chat here first. Kind of analyze that repository and our problem that we're trying to solve, so we can kind of meet halfway. So it's going to take a look at that for us. Now, our decision, we're gonna pivot it from TUI raw NC, but this is okay. So Ralph rejected the TUI frameworks. It's interesting. It's actually, Ralph says like, I don't like this. I'm going to, it says he doesn't like it, but I mean, it's not smart like that. So side quest kill momentum. We're gonna have a reader. Can we have a reader? Is it good with JavaScript? I'm talking like a good reader that is convincing kind of natural language processing that we could add. Kind of just reads the text. Okay, let's check analysis. Okay, out of scope. My principal says it's out of scope. Must not introduce user package. I'm constantly overriding this, which makes sense because Ralph is evolving. So let's actually go here. I think Ralph is evolving. Copy. We're gonna put this. Ralph is evolving. Introducing TUI. We're gonna put TUI. We're gonna put the text over terminal user interface. So now how is that going to work? We have multiple views, we have data, we have layout, input, cross-platform, V2 architecture. Will solve a lot of issues because now we'll see our task in line. We'll see our logs. We'll see our key bindings that we can interact with it. We shall also see what else we will see. We can see more content, and this is its vision for the user interface, where we can have tasks, we can see the outputs, what is being executed, and this is going to be Ralph version 2. So we are already at Ralph version 2. So let's say now within 1 hour and 50 minutes, Ralph has evolved from a prototype to version 2.0. Okay, 2.0, which is TUI. Okay, and now we can pause, resume, skip, and quit, and we know how many episodes we're going to run. So I'm going to let Ralph. Okay, so now the GUI is a fallback. Let's see. The raw CLI is going to be a fallback, but by default, all our development effort will be in our TUI. Now is Ralph ready to handle this task? As in to start through the process and actually finish it. I want Ralph to do it. Yeah, I want Ralph to do it. Okay, so now let's check our code. We're going to go into, please like and subscribe because we are getting wonderful premium content that is actually on YouTube for free, and it's exactly what we need in this current day and age where we're not just building products, we are actually vibing in a professional way, if we want to say it like that, which is kind of wonderful. It's software engineering with a touch of it's like we're basically trying to find the sweet spot between raw vibe coding where anything goes and wasting tokens, and actually creating something the proper way, or using our system using our tokens in the most optimized way, because I think it's important. I want to switch to light team. Is that not hackery enough? Because it has this interesting artifact at the back, and I want to see which one doesn't have it. That underlined. I don't know where that rendering is coming from. This seemed to be the most contrast and readable version of it, so we'll keep that. Golden text. Okay, I think we'll keep that. Now, has anybody liked our page yet? And that would be very, very important. We're going to take a break, and before we do that, I think we can use a more advanced system. We can use a better API that is more natural. But the question is, because it's in the browser, what can we do? Okay, now let's see. We're gonna make Ralph ready for our new. We're gonna update our principles and no web UI. We're not gonna introduce databases yet. Okay, we're gonna make it in scope. Okay. If I understand correctly, our TUI will be in scope, right? And also we can increase the threshold for how many files will be added. Okay, if only, I don't know what, you would have to estimate how many files will be added, but let's not, let's say no more than 10 files. Let's keep that for now. Okay, so we are gonna give it some, oh, okay, so it's building, and all right, let's make the reader, let's file that in ideas, and then we're going to switch back to our slide system to improve it. Let's commit the code that we have. So we're gonna switch to we're gonna take a break, but while we're taking the break, I'm not going to leave you guys alone. I'm going to make sure that you guys get to listen to some of our audio, which is about let's see if that works. First, let's see if our audio will work. Can we increase that? Okay, that's good enough. Okay. Let's
there's this absolute obsession right now in the tech world.
Oh, definitely.
And frankly, we're guilty of it on this show too. It's all about context.
Bigger context windows, right? It's the dream, the holy grail.
Exactly. We want agents that remember everything. This omniscient super employee who knows why you made some obscure decision 3 months ago.
An AI with a photographic memory for your entire startup's soul.
Yes. We treat memory as if it's the same thing as intelligence.
Yep.
But I've got this documentation here today that argues the exact opposite.
Oh, this should be interesting.
We're looking at something called the Ralph pattern, specifically the Ralph Sharp and VibeCoding versions. And the core idea is, well, it's wild.
Go on.
It says to build complex software, you don't want a genius AI. You actually want A dumb one.
A dumb agent.
One that wakes up, works for 5 minutes, and then immediately dies.
It sounds incredibly harsh when you put it that way. Dumb and dead.
It does.
But when you dig into the engineering behind this episodic AI agent loop, it's not a quirk. It's a really rigorous architectural solution.
A solution to what, though? Because
Yeah.
to me, and probably to most people listening, an agent that remembers everything sounds strictly better. Why would I want an amnesiac coder?
The problem is context drift.
Good.
Think about the last time you had a really, really long coding session with a standard chatbot. The first 10 turns are great.
Oh, yeah, it's amazing. Knows all my libraries. The code is clean.
But what about turn 30 or turn 50?
Oh, I've been there.
Ooh.
It starts making things up. It forgets we're using Python. It gives me JavaScript. It hallucinates functions that don't even exist. It feels like it gets tired.
Precisely. That is the genius agent failing. As that context window fills up, the signal-to-noise ratio just plummets.
It gets confused.
It gets confused. It mixes up old instructions with new ones. And that's not even mentioning memory bloat. You're paying for those tokens every single time. So the Ralph pattern argues that reliable software isn't built by a genius in one long marathon. It's built by a fresh worker doing one atomic thing perfectly and then vanishing.
Vanishing before they have a chance to get confused.
Exactly. So the solution to the AI getting confused is don't let it live long enough to get confused.
The source material calls Ralph a dumb episodic worker.
He's not designed to hold the world in his head. He's designed to execute a loop, a very specific and, as you said, somewhat tragic loop.
Tragic is right. Let's walk through this Ralph cycle. The documentation lays it out as a strict 5-step process. Step 1 is wake up.
Right. And this wake up is unique because Ralph is stateless. When an instance spawns, it has zero memory of the past.
None at all.
It doesn't know if the last attempt failed. It doesn't remember your coding style unless it's written down somewhere. It is a complete blank slate.
Which brings us to step 2. Read state. If he has no brain, he has to get his bearings from somewhere.
Exactly. He reads the current situation strictly from files on the disk. This is a critical distinction.
Not a database, not a chat history.
Well, he looks at the code as it exists right now. The file system is his only reality.
Okay. Then step 3, do one task.
And the emphasis is on one. This isn't refactor the entire database layer.
No.
It's add this specific column to this specific table. Atomic, verifiable. He does that one thing.
And then the part I struggle with emotionally. Step 4, die.
The process terminates, memory wiped, gone.
Poof. And step 5, repeat.
Ooh!
A brand new Ralph wakes up. It's basically Groundhog Day for software engineering.
It is, but look at the engineering upside. If you kill the process after every single task, you mathematically eliminate context drift.
Ralph never gets tired.
Never. He never gets confused by an argument you had 5 minutes ago because he literally wasn't there for it. He wakes up, sees what needs to be done, does it, and leaves.
The docs compare this to a reconciliation loop, like in Kubernetes. Now, that's a bit of infrastructure jargon. Can you break that down?
Sure. So in a system like Kubernetes, you have two ideas of reality. You have the actual state, the messy truth of what's happening right now,
Okay.
and you have the desired state, what you want to be happening. A controller just constantly looks at the difference and nudges the actual toward the desired.
So it's always asking, are we there yet? No. Fix it. Are we there yet? No. Fix
That's
it.
it, exactly. And Ralph is doing the same thing for code. The desired state is the implementation plan. The actual state is the source code on the disk.
And Ralph is just the little nudge that closes the gap.
One task at a time. He doesn't need to understand the whole system. He just needs to close the gap for one task.
This brings us to how Ralph,
Yeah.
well, thinks or doesn't think. The VibeCoding docs use this great analogy of a clean room versus a workshop.
Ah, yes, the dual brain strategy. It's smart because LLMs that are good at planning are often expensive and slow.
While the ones that are good at coding need to be fast.
And decisive.
Yeah.
So in the clean room, you have the thinker.
The architect.
Right. It uses a high-level model like Gemini or GPT-4. It's not writing code. It's analyzing specs, planning strategy. It's looking at the blueprints.
And it creates that desired state, the plan.
Exactly. But, and this is key, you don't want the architect pouring the concrete. They overthink it. That's where Ralph comes in. Ralph is in the workshop.
He's the doer.
He's the doer. He's using a different tool like the Claude CLI. He's got grease on his hands. He's touching the file system. He's not philosophizing. He's just fixing syntax errors.
It's a classic separation of concerns. One brain to dream it, another to build it.
And the builder brain is disposable, which is much safer. If the builder messes up, you just spin up a new one.
Okay, so let's get into the weeds of what Ralph is actually doing during his short life. The source material mentions two distinct modes, plan and build.
They do, and these modes fundamentally change the prompt and the permissions the agent has.
So let's start with mode 1, plan.
In plan mode, the agent, the planning instance, is analyzing specifications. It reads the requirements, looks at the existing code.
But its goal is not to write code.
Right. Its only goal is to generate one specific file, implementationplan.md.
And the documentation is super strict about this. It says the prompt explicitly orders the agent, do not implement anything, plan only. Why the all caps?
Because of that drift we talked about, if you try to plan and code in the same session, the model gets distracted. It starts solving tiny problems. Oh, I'll just fix this import, and it loses the big picture.
So by forcing it to plan only, you get a clean to-do list.
A very clean structured to-do list. It's not just a text blob either. It's structured markdown with state markers.
Right, like empty brackets for pending tasks.
And that sets the stage for mode 2, build.
This is where the rubber meets the road.
In build mode, a Ralph instance wakes up. He reads that implementation plan.md. He finds the first pending task. And here's the discipline. He implements only that task.
So if the task is update the CSS for the login button, he just does that.
Just that. He doesn't touch the footer. He doesn't optimize a database query. He just updates the CSS. Then he runs verification. This is crucial. He runs a build command or a test. He checks his own work.
And if it passes?
He goes into the markdown file, marks the task with an X for completed, and then he dies.
And if it fails?
Yeah.
What happens then?
He does not mark it done. This is a rule they call back pressure.
Back pressure. I've heard that in, like, plumbing.
Yeah.
How does that apply here?
It's about stopping the flow of bad code. The prompt says, do not move on with broken code. So if the verification fails, Ralph literally cannot check the box.
So he has to try and fix it.
He has to try and fix it. If he can't fix it before his time is up, he dies, and the task stays pending for the next Ralph.
That feels so much safer. It prevents that snowball of bugs where an agent builds feature B on top of a broken feature A.
Exactly. It creates a ratchet effect. You lock in progress one step at a time.
Now, speaking of files, that's a huge design decision here. The source says files are the API. Ralph doesn't talk to a database. He doesn't talk to a server. He talks to text files.
And that's a deliberate constraint. Think about the complexity of giving an AI database access. Connection strings, schemas, authentication. It's a mess.
And it's dangerous. You don't want a hallucinating agent dropping tables.
Exactly. But text files are universal. Every OS gets them. Every LLM understands Markdown. It's the lowest common denominator.
So what are the critical files?
Yeah.
We have implementationplan.md. There's also agents.md. What's that?
Agents.md is like the employee handbook. Every time Ralph wakes up, he reads it first. It tells him, you're a software engineer. Here are the build commands. Here are the coding standards.
It's his identity.
It is. It provides the context he lacks in memory.
And then the specs.md files are just the feature requirements.
Right, keeping the context focused.
But wait a minute, I'm looking at the VibeCoding system diagram, and it does have a database. It stores tasks and ideas there.
It does, yes.
So how does that info get to Ralph if he only reads files? Is there a middleman?
That's where the state sync service comes in. It's the bridge.
A bridge.
Think of it like a one-way conveyor belt. Before a Ralph episode starts, the state sync service queries the database, grabs all the active tasks, and literally writes them out to those markdown files.
So it prints out the instructions for Ralph to find on the shop floor.
Essentially, yes. Database to sync service to files, and only then does Ralph wake up and read the files.
So he's always looking at a snapshot of reality formalized into text.
Correct. It simplifies his entire world. He doesn't need to know SQL, he just needs to know English and code.
I want to look under the hood a bit more. How is this actually running? The source mentions an episode runner.
The episode runner is the component that actually spawns the Claude CLI as an OS process.
And I noticed some interesting flags being used here. The source highlights dangerously skip permissions.
Ah, yes. It sounds dramatic, doesn't it?
I mean, it sounds like something I would get fired for typing. Dangerously skip permissions.
Well, normally Anthropic's tools are designed to be safe. They ask for permission before editing a file. Can I edit this?
Which makes sense if I'm chatting with it. I want to know what it's doing.
Right. But Ralph is an automated worker. You can't be sitting there clicking yes every 30 seconds.
It would defeat the whole purpose.
Exactly. So they use that flag to let Ralph edit files freely.
But isn't he dangerous then? No memory, full permission to delete files.
That's why the other constraints exist.
Hmm.
They limit him using max turns 25, so we can't go off the rails for too long. And more importantly, there's a hard timeout.
About 5 minutes.
Around that, yeah. If Ralph gets stuck or goes into an infinite loop, the episode runner just kills the entire process tree.
It's weirdly ruthless. You're taking too long. You're done.
But that's what makes it robust. In a traditional script, if a process hangs, your whole system stops. Here, if Ralph stalls, you kill him, and the loop controller just spawns a fresh one.
And a timeout isn't a failure of the task, just a failure of that one instance.
Precisely. It trusts that the next fresh instance might just get it right. LLMs are stochastic, they have randomness. The second Ralph might nail what the first one missed.
This architecture just embraces that randomness instead of fighting it.
It does, it's built for it.
There's one more component, the prompt builder. We touched on the plan versus build modes, but it also injects that back pressure rule.
Right. It explicitly tells the agent, do not move on with broken code.
So it's baked into the instructions every single time.
Every time. If the verification command fails, the loop forces him to stop. He has to fix it. This is the let Ralph principle they talk about.
Trust the loop to self-correct over iterations.
Exactly. If the code is broken, the next Ralph will see the broken code, see the failed test, and his only job will be to fix that one thing. Eventually, the system converges on a working state.
It's fascinating. We're moving away from this one giant brain model to, well, a swarm of disposable interns.
I think it points to a future where we stop treating AI agents as digital people and start treating them like compute resources. You don't name a server instance in the cloud anymore.
You just spin them up and down.
Ralph is the same. It's commoditized intelligence.
But, and there's always a but, there is a gap, a missing piece identified in the source material.
Ah, yes. The scribe.
Right. Because we said the sync is one way, database to files,
Yeah.
the bridge only goes one direction.
Exactly. So imagine Ralph finishes a task. He marks it X in the implementation plan.md file. The code is committed, the build passes, the file system is perfect.
But the database?
The database has no idea. It still thinks the task is in progress. The UI for the human managers is stale.
So the worker is done, but he didn't punch out on the time clock.
A perfect analogy. So closing that loop is the next big step.
And the proposed solution is this scribe component.
Yes.
All right, I think we're back. Thank you for watching and waiting while we were taking a little break. So we're back to our programming, and we are going to put the little music again. And now we're going to do the implementation. Okay, so where were we? Can anybody tell me what theme you prefer? What theme do you prefer? You know? Let's go with this. Still have this thing. Let's actually go into some open libraries. Let's go to library and let's see what is available outside of here right now. Let's we're gonna listen to some so to the radio. We're gonna go to, let's go to Synthwave and let's play. All right, so now we were doing the change from text interface to graphical, or rather to the 2B, which is what we're doing. And therefore, without further ado, we're gonna put it in scope. Okay, so we're gonna say, have you put everything? Okay, it's updated. So I'm going to test. That's the moment of truth. Are you ready? This is the quote. This is the line we're gonna give Ralph. We're going to paste it here. Are you ready? Ralph is not recognized. So I'm going to close this terminal to remove the artifact. And we're going to actually ask Claude, why did it say that Ralph is not good? So in the meantime, let's go to our So we are going to talk about computer science principles, because this is important to kind of know. In this project, what are the core computer science principles? Okay, so it's gonna load, and Ralph is working. Let's look at our Git. So Ralph has already created. This is the part I wanted to do, like, okay. It's exploring. It's in the exploration phase right now. We need to add more information, but we don't want to save this. Let's close this. Okay. And let's see. We do not want this. If a session is over, we just close it, close it, close it. And this is, okay, it's exploring the code base. And fail fast is another principle that might be software engineering related. You know, algorithmic complexity and lazy evaluation. Don't compute what you don't need. So that's actually a very important part of it. So let's also take in terms of let's also take in terms of Okay, I'm gonna say, based on our code and our everything that we've been doing, if you could have write like a paper, like a scientific paper, or a spec, or a software requirement document, what would you write? And we see what it does. Okay. Stages. Okay. Now, let's see what we should do now. What should I focus on? It's very interesting. Do you like the music? I do not see a way to... Okay, our microphone is working. So I think we can remove this. We can also remove this. Okay, so we can focus on what we need. What is this one? We can remove this. Oh well, Control Z. Control Z. Okay. Okay. So let's read our specification. let's read our specific, let's copy it. Let's go into we're gonna have our colors like that, and so prompt engineering is this thing people have been talking about, and there are many things we cannot do, so we have to improvise. And also, we're kind of waiting for the next stage of Ralph. It's on task number 211. And what task is it on now? It's on task 3. So it's implementing the header panel with a stage. So we're doing it with minimal supervision, just so we don't have to worry too much. We just want to see it later. If we have a good plan, it should implement it. Let's actually see the plan that it gave us, you know, because that would be important. Let's check the plan to see if it actually is going to do something. And I think this is the stage we should have, is this human stage, where let's do the preview. This is the plan Ralph came up with. I don't know. Okay, so it says that it's going to add the NuGet package. It's going to create a basic structure. So it seems like there's an iDisposable class. We run our loop controller. We initialize our application. This is like setup. So that's like the main, if you want to call it that. And then after it does that, manually test it. Okay, so it's not super detailed. I think this is a part of the process that we'll have to fix. But let's see if our specification give us a better insight upon okay. We added this specification. Where's the specification? Okay. Let's create an infographic. Let's create the audio overview. Let's generate the video. Okay. Now we can't call it episodic agent because it's like an episode, and a genus agent is not going to be, it's going to be too smart for its own good. It's gonna try to do too many things, and that's when things kinda, so the first thing we worry about is context drift and token bloat, and what else? Unpredictable failures, non-resumability. So to fix that, we go with the assumption that it is zero memory, in that we read the state from the files, and that there are so many we terminate, we loop and restart fresh. Okay, So we also, this is the pipeline that we are kind of working on. Is any questions? Actually, guys, can we have some, let's talk for a bit. Where are you from? I don't know. What are you interested in? It's actually okay. So refine, clarify, execute is the process that we employ. Now the life cycle is that what other agents we should think in terms of okay. Okay, so now this is the life cycle. So take some time to read this, to understand, and in fact, let's okay, let's see what Ralph has done. There, I just realized that we need notifications. And let's see if Ralph has done something cool. It says succeeded. And did he finish? Let's go and copy all of this. And let's see if it has done us some good. Before I even launch the application, we'll ask it that question. I'm gonna go here just to see, right? We're gonna ask it the question. And we're gonna see if our Ralph has succeeded. So if you want to understand Ralph, Okay, it's building some stuff for us. What did it say? It says that we completed, you have some remaining tasks. Yeah. Complete the tasks for me. Okay, let's switch gears. I think it will be faster if we just do it ourselves at this point, you know? Because it seems our foundation needs a bit more solidity, you know? Our foundation needs a bit more solidity, and we'll allow all edits in this session. So, you know, I think Ralph, for all its good things, is not always the most. We haven't finished it yet, okay? So while this is working, let's check our specification. I think that's what's going on here. It fails fast, but we also have the no pause philosophy. It should, if it can proceed, bam. If it notices an issue, bam. If it completes, bam. But also the blast radius, that means we should not touch things outside of its scope. It's not gonna go wild on us. It's actually probably safe too. So this is our entry point. It seemed to have made the change So I think now what we can do is we have to test idea, explain this, explain. So I think as an insight, okay, so I'm going to say insights that I've discovered is that it's better to look at the code.
All right, let's dive into something that sounds, well, just... All right, let's dive into something that sounds, well, just plain wrong. We're always told that for AI, smarter is better, right? That a perfect memory is the holy grail. But what if I told you the real secret to building a reliable AI software developer is to make it incredibly forgetful? Yeah, let's explore how forgetting might just be an AI superpower.
I mean, look at this. This sounds less like a cutting-edge AI and more like a mayfly. It seems totally backwards. How on earth can an agent that completely resets its brain every few minutes build anything complex? But you got to stick with me here, because this super simple, kind of weird mantra, it's the key to solving some of the biggest headaches in AI today.
So here's our game plan. First, we're going to look at what I'm calling the genius agent's curse, basically why the super smart approach tends to fail. Then we'll uncover the secret of our hero, the forgetful worker, and its powerful one-task loop. We'll see how boring old text files can replace a complex memory, and finally, we'll put it all together to see why this radical simplicity just wins.
Okay, so let's start with the idea that everyone, and I mean everyone, tries first. You build a genius agent. The goal is to create this one long-running process that keeps the entire project, every file, every rule, every line of code, all loaded up in its memory. It sounds amazing, but this kind of brilliance, well, it has a really dark side. In theory, an AI that remembers everything should be unstoppable, right? But in the real world, that perfect memory is the very thing that makes it so brittle and unreliable when you give it a genuinely hard job, like writing software. Let's break down exactly why that is. So here they are, the four horsemen of genius agent apocalypse. You've got context drift,
a genuinely hard job, like writing software. Let's break down exactly why that is.
So here they are, the four horsemen of genius agent apocalypse. You've got context drift,
a genuinely hard job, like writing software. Let's break down exactly why that is.
So here they are, the four horsemen of genius agent apocalypse. You've got context drift,
a genuinely hard job, like writing software. Let's break down exactly why that is.
So here they are, the four horsemen of genius agent apocalypse. You've got context drift,
a genuinely hard job, like writing.
And this table just lays it all out perfectly. On one side, you have the genius agent. It's stateful, trying to juggle everything in its short-term memory. And on the other, you have the episodic worker. The team behind this actually nicknamed it Ralph, which is the polar opposite. It's stateless. It starts with a completely blank slate every single time. Its state, its memory, isn't in its head, it's written down on the file system. And that makes it incredibly resilient. Now, the engine driving this forgetful worker is a concept called a reconciliation loop. And this isn't some brand new, crazy idea. It's actually borrowed from super reliable industrial-strength systems like Kubernetes. The logic is so simple, it's brilliant. Look at the goal, look at where you are now.
Figure out the one single smallest step you can take to get closer to the goal. Do that one thing, and then start the whole process over, completely fresh. Okay, that all sounds great in theory, but it brings up a massive question, right? If this agent has no memory and only does one tiny thing at a time, how does it ever get anything complicated done? Let's get into the nuts and bolts of how this one task loop actually works.
Here's the magic. It's like a little 3-act play that repeats over and over. First, it wakes up. A brand new process spins up from nothing and reads the project's current status from some simple text files. Second, it acts. It does exactly one small atomic thing. Writes one function, runs one test. That's it. And finally, and this is the most important part, it sleeps. It writes its results back to the files, and then the process completely terminates, taking any memory gunk or context drift with it to the grave.
Now, this little loop doesn't just run wild in a vacuum. It's actually the very last step in a much bigger, more deliberate process. So before the agent even starts executing, it goes through these other stages. It explores the existing code, it refines the goal into crystal clear specifications, and then, and this is critical, it creates a detailed plan, breaking that big job down into all the tiny bite-sized tasks that our forgetful worker is so good at. You can think of it like the agent has two different hats it can wear, but it only ever wears one at a time. In plan mode, it's the architect. It thinks, it analyzes, and it writes out a to-do list in a file called plan.md. In this mode, it's not allowed to write a single line of code. Then, it switches hats. It enters build mode. Now, it's a construction worker. It just reads the plan, does the very next task, and checks it off the list. A beautiful, simple separation of thinking and doing. So, this brings us to the secret sauce that makes this entire system work. If the agent isn't keeping the project status in its memory, where is it? The answer is so simple it's almost funny. It's all just stored in plain old text files. And this right here, this is basically the agent's brain, laid out for you to see. The entire status of the project is tracked in a markdown file with these simple little symbols. An empty checkbox, that task is pending. A tilde, it's working on it right now. An X, it's done. It is so ridiculously simple that a human developer can just open this file and know exactly what the agent is thinking and doing at any given second. And this all points to a really profound idea. Files are the API. Now, API is just a techie term for how programs talk to each other. Instead of some complex digital protocol, this agent's entire communication system is just reading a text file and then writing back to it. That's the whole contract, and that simplicity is the foundation of its strength. And the payoffs you get from this are huge. Your system crashes? Who cares? You just restart the loop, it reads the files, and picks up right where it left off. There is literally zero context drift, because the context is built from scratch, from the files, every single time. Debugging? It's as easy as opening Notepad. And my favorite part, a human can literally hit pause, go into the plan file, change the instructions, and hit play again. It's amazing. So let's bring it all home. Why does this dumb, forgetful approach actually work so much better than the genius agent? Well, it all boils down to a few core, battle-tested principles that guide the whole system.
Think of these as the 5 commandments for building a resilient agent. 1 atomic, verifiable task per episode. Files are the only way to communicate, period. Back pressure, which is a fancy way of saying if a test fails, you stop immediately and don't make things worse. A fresh context on every single loop, and my absolute favorite, let Ralph, which is just a fun reminder to trust the process. Trust that tons of tiny, correct steps will eventually get you to a big, correct result.
This final chart just drives the whole point home. When you put this model, called Ralph Sharp, side by side with other famous agent systems, the difference is just night and day. Look at that first column. Everyone else is clinging to this idea of persistent in-memory context. Ralph Sharp is the only one with zero memory. And its state persistence? Not some complex vector database, the humble, simple file system. It's not just an improvement, it's a completely different species of AI. And that really leaves us with this one big, provocative thought to chew on. We have been obsessed with building AIs that can remember everything, like an elephant. But maybe, just maybe, for building AI systems that are robust, predictable, and can actually get real work done in the messy real world, the secret isn't remembering more. It's the disciplined, powerful art of knowing exactly what to forget.
Yes, gray screen background, nothing else. And I think, shouldn't our thing resize as we resize our terminal? Okay, so let's let's go back to our well, this is building. We will listen to our infographic again.
All right, let's dive into something that sounds, well, just plain wrong. We're always told that for AI, smarter is better, right? That a perfect memory is the holy grail. But what if I told you the real secret to building a reliable AI software developer is to make it incredibly forgetful? Yeah, let's explore how forgetting might just be an AI superpower.
I mean, look at this. This sounds less like a cutting-edge AI and more like a mayfly. It seems totally backwards. How on earth can an agent that completely resets its brain every few minutes build anything complex? But you got to stick with me here, because this super simple, kind of weird mantra, it's the key to solving some of the biggest headaches in AI today.
So here's our game plan. First, we're going to look at what I'm calling the genius agent's curse, basically why the super smart approach tends to fail. Then we'll uncover the secret of our hero, the forgetful worker, and its powerful one-task loop. We'll see how boring old text files can replace a complex memory, and finally, we'll put it all together to see why this radical simplicity just wins.
Okay, so let's start with the idea that everyone, and I mean everyone, tries first. You build a genius agent. The goal is to create this one long-running process that keeps the entire project, every file, every rule, every line of code, all loaded up in its memory. It sounds amazing, but this kind of brilliance, well, it has a really dark side.
In theory, an AI that remembers everything should be unstoppable, right? But in the real world, that perfect memory is the very thing that makes it so brittle and unreliable when you give it a genuinely hard job, like writing software. Let's break down exactly why that is. So here they are, the 4 horsemen of genius agent apocalypse. You've got context drift, which is when the agent's brain gets so cluttered with old info it starts making stuff up. Then there's token blow. Its memory just keeps growing and growing until it hits a hard limit and the whole thing just crashes. This leads to these totally unpredictable, random failures. And the real killer? Non-resumability. If that agent stops for any reason, poof! All that work is gone. You're right back at square one. Okay, so if the genius approach is fundamentally broken, what's the alternative? Well, this is where our unlikely hero steps onto the stage, the forgetful worker. This is an agent built on a truly radical idea, that forgetting isn't a bug, it's its most important feature. And this table just lays it all out perfectly. On one side, you have the genius agent. It's stateful, trying to juggle everything in its short-term memory. And on the other, you have the episodic worker. The team behind this actually nicknamed it Ralph, which is the polar opposite. It's stateless. It starts with a completely blank slate every single time. Its state, its memory, isn't in its head, it's written down on the file system. And that makes it incredibly resilient.
Now, the engine driving this forgetful worker is a concept called a reconciliation loop. And this isn't some brand new, crazy idea. It's actually borrowed from super reliable industrial-strength systems like Kubernetes. The logic is so simple, it's brilliant. Look at the goal, look at where you are now. Figure out the one single, smallest step you can take to get closer to the goal. Do that one thing, and then start the whole process over, completely fresh.
Okay, that all sounds great in theory, but it brings up a massive question, right? If this agent has no memory and only does one tiny thing at a time, how does it ever get anything complicated done? Let's get into the nuts and bolts of how this one-task loop actually works.
Here's the magic. It's like a little 3-act play that repeats over and over. First, it wakes up. A brand new process spins up from nothing and reads the project's current status from some simple text files. Second, it acts. It does exactly one small atomic thing. Writes one function, runs one test. That's it. And finally, and this is the most important part, it sleeps. It writes its results back to the files, and then the process completely terminates, taking any memory gunk or context drift with it to the grave.
Now, this little loop doesn't just run wild in a vacuum. It's actually the very last step in a much bigger, more deliberate process. So before the agent even starts executing, it goes through these other stages. It explores the existing code, it refines the goal into crystal clear specifications, and then, and this is critical, it creates a detailed plan, breaking that big job down into all the tiny bite-sized tasks that our forgetful worker is so good at.
You can think of it like the agent has two different hats it can wear, but it only ever wears one at a time. In plan mode, it's the architect. It thinks, it analyzes, and it writes out a to-do list in a file called plan.md. In this mode, it's not allowed to write a single line of code. Then, it switches hats. It enters build mode. Now, it's a construction worker. It just reads the plan, does the very next task, and checks it off the list. A beautiful, simple separation of thinking and doing.
So this brings us to the secret sauce that makes this entire system work. If the agent isn't keeping the project status in its memory, where is it? The answer is so simple it's almost funny. It's all just stored in plain old text files.
And this right here, this is basically the agent's brain, laid out for you to see. The entire status of the project is tracked in a markdown file with these simple little symbols. An empty checkbox, that task is pending. A tilde, it's working on it right now. An X, it's done. It is so ridiculously simple that a human developer can just open this file and know exactly what the agent is thinking and doing at any given second.
And this all points to a really profound idea. Files are the API. Now, API is just a techie term for how programs talk to each other. Instead of some complex digital protocol, this agent's entire communication system is just reading a text file and then writing back to it. That's the whole contract. And that simplicity is the foundation of its strength. And the payoffs you get from this are huge. Your system crashes? Who cares? You just restart the loop, it reads the files, and picks up right where it left off. There is literally zero context drift because the context is built from scratch, from the files, every single time. Debugging? It's as easy as opening Notepad. And my favorite part, a human can literally hit pause, go into the plan file, change the instructions, and hit play again. It's amazing.
So let's bring it all home. Why does this dumb, forgetful approach actually work so much better than the genius agent? Well, it all boils down to a few core, battle-tested principles that guide the whole system.
Think of these as the 5 commandments for building a resilient agent. 1 atomic, verifiable task per episode. Files are the only way to communicate, period. Back pressure, which is a fancy way of saying if a test fails, you stop immediately and don't make things worse. A fresh context on every single loop, and my absolute favorite, let Ralph, which is just a fun reminder to trust the process. Trust that tons of tiny, correct steps.
All right, let's dive into something that sounds, well, just plain wrong. We're always told that for AI, smarter is better, right? That a perfect memory is the holy grail. But what if I told you the real secret to building a reliable AI software developer is to make it incredibly forgetful? Yeah, let's explore how forgetting might just be an AI superpower.
I mean,
I think we are back. Our text TUI is actually launching. We see our task here. Okay. Output. So I think we need to yeah. So that's a great achievement. And we'll continue this development tomorrow. Thank you guys for being there with me. That was wonderful. I might come back later, but if I get 2 more likes, I'll come back later in the next 5 minutes because that'll encourage me. It's like, okay, people actually are watching. I mean, I would probably do it anyway. So, but we'll see. So you have the stages. So, and then It's done. So Ralph was actually working. Okay. So Ralph was working, and that's it. So now we have a complete system, and it was nice. 3 hours. Wonderful. Thank you, and have a wonderful night, okay?